Okay, so let's take a look at some stoichiometry, one of my favorite words in the entire English language. But basically, we're just going to do some calculations with our balanced chemical equation. So remember, we need to start with, and we have a balanced chemical equation. So you've been given here that you have 2 moles of aluminum reacting with 3 moles of sulfuric acid to produce 1 mole of aluminum sulfate and 3 moles of hydrogen. And the question says, how many grams of aluminum do you need to be able to produce 1.3 grams of aluminum sulfate? Now, there's 2 ways to approach this. So the first way, I'm gonna work through both. Okay, so if you're good after the first one, you can stop the video. If you want to see the second way to think about it, you can keep watching. Okay, so let me just sort of map it out first. So what we're going to do is we need to remember and recognize that these coefficients, these numbers here, those all are in moles, okay? But the question is asking us in grams, okay? And you have to convert between those two. You cannot go straight. If our relationship between what we are given and what we want to find out is they only gave us a relationship in moles, then we cannot use the mole relationship to figure out my grams. So with that in mind, the map that we will follow is, well, I cannot go grams to grams. There is no direct way, the way this is written, to go grams to grams. So what I'm going to have to do, since I cannot do what seems to be the easiest, I have to first convert from grams into moles. And remember, when you do that, you are going to use the molecular weight or the molar mass, okay? And then once I have my value that I was given in terms of moles, now I can actually convert from moles of one substance to moles of the other using that good old mole ratio that comes from our balanced chemical equation. And then once I've done that, then I can convert back into the units that I'm being asked to find, which is grams, using the other molecular weight. Okay, so in this problem, the molecular weight, I'm not going to go through how we calculated it, but that can be in another video. The molecular weight of aluminum sulfate is 342 grams per mole. Okay, you need, and then the molecular weight of aluminum is 27 grams per mole. And then the other part of this that we need to recognize, the mole ratio, looking at the coefficients, we know the mole ratio here is that there are 2 moles of aluminum for every 1 mole of aluminum sulfate. All right, so that's all of the bits of information that we need to have available to us. So let's go ahead, and I'm going to write this out in dimensional analysis. So I'm going to write what I'm given first. Always write what you're starting with first. And I am starting with 1.3 grams of aluminum sulfate. Okay, and looking at our roadmap here, right, the first thing I have to do is convert that from grams into moles, and I'm using my conversion factor here of 342 grams per mole. And so I'm going to multiply that by 1 mole, because that's the unit I'm trying to get to. So we've got our moles of aluminum sulfate, and then it's 342 grams of aluminum sulfate. And I wrote it that way because I want to be able to cancel those units of grams. Okay, so at this point, I am actually right here. Okay, so then I'm going to go from moles to moles. So what am I doing? I'm going from moles of aluminum sulfate to moles of aluminum using our mole ratio, which we already wrote. So let's go ahead and do that. And I'm going to have my next conversion factor. I want to get rid of moles of aluminum sulfate, so I'm going to be writing that one in the bottom. That's my 1 mole aluminum sulfate, SO43. And I want to convert that into moles of aluminum, and that's my 2 moles of Al, right? So that allows me now to cancel the moles of aluminum sulfate, top and bottom. And then, let's move this over just a bit so I'm not running out of space, okay? Now we have moles of aluminum, okay? And we're right here, and we need to get up to grams of aluminum, and that's where we're going to use the molar mass of aluminum as our next conversion factor, all right? And so we have 1 mole of aluminum, and that from the periodic table we know weighs 27 grams of aluminum. That allows us to get rid of the moles of aluminum. So remembering back to our algebra, when we want to go about solving this, because now everything is there and all we have to do is put it in the calculator. Remember, if it's on top, we are multiplying, right? So the 1.3, 1, 2, and 27, remember all of those are going to be multiplied together. And remember at the bottom, you multiply everything on the bottom, and then you divide the top by the bottom, okay? So when you go and you put that into your calculator, which the way I do it, guys, because it makes it faster for me, is in my calculator will literally type 1.3, and then I come over here and I could type times 1, but then I would type divide by 342, and then I would say times 2, and then if I wanted to use the 1, I'd say divided by 1, and then I would say times 27 and then divide by 1. That just streamlines it for me. You don't have to do it that way. Either way, if you put everything in correctly, either way, you will get the correct answer, which should be 0.21 grams of aluminum. Now, that also uses our significant figures, okay? So in just a second, the video will go on, and I will show you another way to solve the same problem that does it in a slightly different way. And actually, I'm going to give credit to Mr. Deal of Knightdale High School, because he's the one who kind of saw that, and I just thought it was a neat approach. So I'll walk you through that one here in just a second. In this approach, what we're going to do is, instead of leaving the balanced chemical equation in terms of moles, like we have here, right? All of these numbers right here are all moles. What we're going to do is we are going to convert these from moles into grams. So instead of saying 2 moles of aluminum, I'm going to multiply by the molar mass of aluminum. And instead of 2 moles of aluminum, that's the same as saying 54 grams of aluminum. Okay? And then I'm going to do the same thing with the rest of them. So instead of 3 moles of H2SO4, I'm going to convert that and multiply it by the molar mass, which is 98 grams per mole. And then that means that 3 moles of H2SO4, that actually weighs, it's like having 294 grams of H2SO4. And then I'm going to multiply this aluminum sulfate by 347 grams per mole, because 1 mole of aluminum sulfate weighs 347 grams. That's the whole point of a molar mass, right? So we have 347 grams of aluminum sulfate. And then I'm going to convert my hydrogen by multiplying that by 2, because that's 2, sorry, don't ever forget your units. 2 grams per mole, so that means that's 3 grams of hydrogen is the same as saying 6 grams. 3 moles of hydrogen is the same as saying 6 grams of hydrogen. Now, if we do this, now I know that was a lot of work, and I did it very quickly, but that was a lot of work. But if we do this, take a look at what happens. The question still is saying, hey, I want to make 1.3 grams of this aluminum sulfate, and it's asking, hey, how many grams of aluminum is it going to need? So if we have converted everything into grams, watch what happens. We still start with 1.3 grams of aluminum sulfate, but now my conversion is so much easier. Take a look. I'm going to use these numbers now. So I've got 54 grams of aluminum will give me 347 grams of aluminum sulfate. So now when I'm doing my dimensional analysis, I'm going to write 347 grams of aluminum sulfate on the bottom, and I'm going to write 54 grams of aluminum on top. My aluminum sulfate still cancels, and guess what? When I put this in the calculator, I put 1.3 times 54 divided by 347, and you guessed it, it will still come out to the correct answer of 0.21 grams of aluminum that is needed. So I'm just going to call this the Mr. Deal method, since he's the one who saw it, and I just thought it was fabulous. I hope it helps you guys, and stay safe, stay well, and we hope to see you back in school soon.